Good. All right. Welcome to the meeting. All right. This is a final year review. So this is a very important milestone before completion. Uh, Now, this is a very stressful time, but just be calm and just move on. I don't want the students to get stressed out. So when you're ready, Devan, you can start anytime.
All right, thank you, Alex. And
Okay.
thanks everyone else for taking the time to be a part of this today. Yes, I'll be presenting my final year review. So the title here is The Relationship Between Physical Activity and Sleep in Children. So just getting into it. Yep, there we go. Just a quick overview of what we're going to all be talking about today is my 3 studies. So first one being a systematic review meta-analysis. The second study is a validation study for this GENEActiv accelerometer, and the last study is an acute and longitudinal sort of investigation into this association. So I'll get into each of those more as we go. First of all, though, some brief background information. We know that physical activity and sleep are important. We know, especially for children in their time when they're growing and maturing, that getting adequate physical activity and adequate sleep can be and is very important for them. Evidenced here, we have the Australian government with 24-hour movement guidelines now, including the recommendation of 60 minutes of physical activity per day, and also 9 to 11 hours for 5 to 13-year-old kids of sleep. The problem is that many children fall short of these recommendations. By some estimates, 26% meet physical activity guidelines, and only 42% meet sleep recommendations. So some work to do there still. The problem with not meeting the guidelines is that they're associated with obviously positive things. So not meeting those guidelines puts you or children at a higher risk of a variety of different outcomes, negative health outcomes. So actually, there's a lot of common associations here. So poor sleep and inadequate physical activity are both related to poor academic performance for kids, poor or increased risk of obesity and diabetes, but also things like mental health, increased risk of depression. So aside from being related in this way, having common associations, I've been interested in seeing if one activity is influencing another, as in, if you're being more physically active, are you more likely to get to sleep better? And if you're sleeping better, are you more likely to have better physical activity habits the next day and more motivated to work out and things like that? And so far from the evidence, it suggests in older populations that it is the case. So this meta-analysis here in adults, looking specifically at exercise and its effect on sleep duration, found a moderate effect size of 0.25, meaning that more exercise, more regular exercise, resulted in longer sleep durations. Another meta-analysis on a younger population of adults, young adults and adolescents, took a slightly different approach, mostly focusing on the difference between subjective and objective measurements, but found that when you look at objectively measured physical activity and objectively measured sleep, that there was actually quite a large effect size of 0.102. So suggesting that there is a relationship here where you're more active, you're sleeping better. However, so far there had been no meta-analyses like this done in children, well, until now. So this was my first study as meta-analysis and systematic review, which I was very happy to have published earlier this year in the Journal of Sleep Medicine Reviews. The objectives of this analysis were to look at the association between physical activity and sleep, specifically in children. But I also wanted to see if there was evidence of direction. So where, like in the adults, it was just the effect of exercise on physical activity. I wanted to look if it would go both ways. So does physical activity help sleep? And does sleep also help physical activity? And then I also wanted to identify potential moderators of this association. So within the meta-analysis, I followed the PRISMA guidelines for reporting the meta-analyses. My included studies, I was looking for any studies that included a quantitative analysis of physical activity and sleep for children between ages 3 and 13 years old. And I did exclude studies based on whether they were published in English or not. I searched 8 databases, so I found quite a few records, almost 30,000, almost 14,000 duplicates. But I did have to screen 16,000, and in the end included only 47. So overall, an inclusion rate of like 0.3%. Of those studies, we actually covered quite a few kids and represented a lot of different places. So almost 62,000 kids included in all the studies, with the mean ages between 3.9 and 13.4, with only Africa not being represented in any of the studies. One of the limitations of this was that they're almost all cross-sectional studies, so only 1 longitudinal and only 2 experimental studies. But a good thing was that mostly accelerometers were used, so mostly objective measures were used at least to measure one of the variables, either sleep or physical activity or both. And looking at the caterpillar plot, you can see that everything hovers right around 0. So we got a range of -5 to about +0.65. And when you run the main analysis, that's kind of what we see. An overall correlation coefficient of 0.02, which is quite small and non-significant. However, there was a lot of heterogeneity in the model. So 97.2% of that was of heterogeneity. So we did test some moderators: age, gender, risk of bias, study quality, the direction of the study, so whether they were looking on sleep on physical activity or physical activity on sleep, or didn't specify a direction, and what type of measurements they used. And running these moderators, I didn't find that any of them accounted significantly for the heterogeneity. They didn't affect the relationship significantly at all. Another way to break this down, because there was a lot of variety in the way these studies looked at this relationship. So I extracted in total 24 different physical activity variable outcomes and 26 different sleep variable outcomes. And so to try to make sense of this and to run a subgroup analysis, I grouped these into similar categories. So whether we're talking about light physical activity or like total physical activity is more of a subjective rating, like how active are you normally? And same thing for sleep. When I ran the subgroup analyses, there's obviously a lot going on here, but I'll just point out a couple things down here. The only significant effects were for vigorous physical activity and sleep duration, and for vigorous physical activity overall. But you can still see that it's quite a small correlation, but it is positive, meaning as you're more vigorously active, you get a little bit more sleep duration. But again, lots of heterogeneity there in some of these models. So some of the key points of this meta-analysis was that there is a lot of inconsistency between the results, but also how these studies measure this association, finding very little association overall, with a lot of high heterogeneity in the models. However, vigorous physical activity, though weak association, is positive, has a positive influence on sleep. And there's very few longitudinal and experimental studies that have been conducted, and that's an area for future research. My second study is the validation study of the GENEActiv accelerometer. Basically, what I was trying to look at here is whether the small accelerometer worn on the wrist could accurately estimate sleep compared to polysomnography. So just looking at these two, you can tell that the image on the right is has a lot more going on. That's polysomnography. That's an at-home sort of device, which is the device I've used in this study. But it's very cumbersome. It's not comfortable to sleep with. You can imagine on a child, the wires look even more than this guy. But it's not feasible in large scale studies to measure sleep with polysomnography. So if we can have a small wrist-worn accelerometer instead that measures sleep based on the change of arm angle and accurately measuring sleep based on brain activity, then we'd much rather use those. The GENEActiv is actually used quite a lot in research for movement behaviors. Has been validated. So these are some of the studies that have validated the GENEActiv for different activities: sedentary time, physical activity, sleep, most recently by Van Hees. But as you can see, there's no validation study for sleep in children. So that's where this study is meant to fall in. I've recruited 8 to 11-year-old children, so trying to keep the age range small, and I was avoiding kids with sleep disorders, try to get normally developing kids. And I had a lot of issues with recruitment early on, where I was trying a lot of different things. Basically, what it comes down to is the things I was trying. Whoops, wrong way. Things I was trying that were free were not working, and then the things that I did that I spent money on did work. So, for example, I was talking to everybody that I know. I was posting online. I was even having articles put in newspapers talking about the study, try to get the information out there. And I got maybe like 10 expressions of interest and ultimately no participants from those. But when I used some of my candidature funds to buy Facebook ads and to offer some gift cards as compensation, within a couple of weeks, I had about 65 expressions of interest, over like 11, I think, consent forms, and I've collected data on 3 so far. And it was going very well, and I was moving things right along until most recently, when obviously we're in this current situation where no face-to-face data collection is allowed for the foreseeable future. So moving forward with this study, I'm currently in discussion with my supervisors about how to move forward with this, looking at options, possibly looking at a different way to get at this sort of information with data that we already have, because it doesn't seem like the restrictions are going to be lifted before my thesis is going to finish. So moving on to the last study, this is the study of looking at acute and longitudinal associations. And so what I mean by that is longitudinal relationships, looking at more like habitual sort of, how does your sleep affect your physical activity down the line, like in the future? So maybe how you sleep now, is it affecting how you sleep like in a year from now? And as I said, there was only one meta-analysis. In my meta-analysis, only one study has looked at a longitudinal investigation like this in children. The other option is to look at sleep more acutely, or day to day. So how is my physical activity today going to affect my sleep tonight? Or how is my sleep last night affecting my physical activity today? The one study done in children looking at longitudinal associations did find a positive association in 13-year-old girls, looking at subjective ratings of sleep problems. So as physical activity went up, ratings of sleep problems went down. And there's been 3 studies in children looking at this more acute relationship or day-to-day relationship. One by Vincent and colleagues found no association. So really within this acute thing, we're getting a mixed bag, but no association found here between accelerometer measures of vigorous activity or moderate to vigorous activity and sleep duration. Whereas this study found a negative association. So as kids were more active, they were sleeping less. And in this most recent study, they found positive and negative findings. So actually, it was a positive association for physical activity during the day on sleep duration that night or sleep onset that night, but sleep duration during the night was associated with less physical activity the next day. So mixed findings so far. So for my study, I'm going to look at both. I'll look at longitudinal and acute associations using the iPlay data. We have data from 3 years, and within each year there are 8 days of data. So we can look at both kind of associations. So starting, this sample has just over 1,200 kids, ranging from 7 to 13 years old. However, there are less kids that have valid accelerometer wear time. So to include in this study, they need to have at least 10 hours of data and at least 4 days of valid days, with at least one weekend day included in that. And to run my acute analyses, I've used linear panel regression models with fixed effects. So I did compare that to random effects models, and using the Hausman test, it was less than 0.05, indicating that the fixed effects models were a better fit or more consistent with the data. So I stuck with fixed effects. And to look at longitudinal associations, I've used parallel process latent growth modeling, which I'll show a little bit more later. But obviously, there's a lot going on here. This is the outcomes from the acute analysis with physical activity as a predictor. But I just want to focus here on one to kind of outline kind of the pattern of findings we're finding with this acute analysis. Vigorous physical activity predicting sleep duration with a beta of 10.266. So just to make sense of that, vigorous physical activity is in a proportion of wake time, and the average wake time is about 16 hours. So you can think about 1% increase in vigorous physical activity is about 10 minutes of wake time. And that's associated with sleep duration at 10.26, meaning that a 1% increase or 10 minutes increase in vigorous physical activity is associated with 10-minute increase in sleep duration. And we're finding that's fairly consistent with the other physical activity predictors. And when you look at it the opposite direction, it's positive as well, with sleep duration predicting vigorous physical activity. And that kind of falls in line with my meta-analysis, finding vigorous physical activity to be positively associated with sleep duration. The other analysis is the longitudinal parallel process growth model. And I'm going to break this down just so it's clear what's going on here. First of all, we're using the data at each time point to create some growth variables. So each time point goes into sleep initial, the sleep intercept, and the sleep slope. So how sleep changes over time. And we do that same thing down here with physical activity. And this allows us to compare the growth variables with each other, right? So how does initial sleep compare to change in sleep over time? Or with physical activity, you can look at how initial physical activity relates to changes in physical activity over time. We can also look at how the initial sleep is compared to initial physical activity levels, or how the change in sleep is related to the change in physical activity over time. And we can also look at how your initial sleep predicts your change in physical activity, or how physical activity initially is related to your change in sleep over time. Now, these produce quite a lot of numbers and models. Again, just to keep consistency, let's focus in here on sleep duration and vigorous physical activity. So when I put these numbers into the model, this pattern of results is pretty consistent with the other associations as well. So not too much going on. If you look across the top, initial sleep duration, not significantly related to sleep duration change, but initial vigorous physical activity is significantly related to the change in vigorous physical activity. What that is telling us is that the higher your initial vigorous activity is, the less change you have over time. So if you stay high, if you start high, you tend to stay high. But no association there between initial sleep and initial physical activity. Same thing for the change, no sleep duration change with vigorous physical activity change. And the cross paths are also not significant. So this kind of findings are consistent with the other models that I've been finding. And that basically wraps up my final review. In summary, I looked at a meta-analysis showing an inconsistent but little association between sleep and physical activity. I've given an update on my GENEActiv sleep validation study, and I've shown off some of the results from my acute and longitudinal analysis showing that there are some positive signs for acute, but not so much for longitudinal. Thank you for your time today, and special thanks also to my supervisory panel. And are there any questions?